Hi, my name is Maciej or Mac Przepióra, and today I would like to talk about the last mile of microservices, which is about why or how do you present data in a microservices-based system. So how do you connect your front end to the backend that is microservices-based? So let's think about microservices in general. Why people develop their systems using microservices architecture? So one tempting answer is that's just fashion. So there is a quote from Steve Yeager, writer and developer, and he says the global programming community is fashion driven, and it's very much like a real life fashion. So there is probably a fashion for using microservices, but there are other reasons why would you want to use microservices. So let's think about what happens if you want to develop a huge system without using microservices architecture. What you usually end up with is a big ball of mud anti-pattern, right? Probably pretty much anyone who develops bigger systems have seen this pattern or anti-pattern. Everything is connected to everything, everything depends on everything, and it's basically a a ball of mud, right? What's nice with a ball of mud is that you can stick more mud into it and it will still hold, right? But that's pretty much the end of the conveniences that it provides. So big ball of mud is too big to be understood by one developer. And for example, onboarding new developers will take forever. When you have someone new joining the team, they need like 6 or 12 months just to understand what's happening in the system and how to provide simple features to it. So it's very expensive to onboard people. Only few key employees in the company know the core or most of the stuff and know how to do things. So only those few people are really productive. Everyday development is very slow because, well, basically, you need to understand all the intricacies. You need to understand all the dependencies that you want to use. So everyday development is slow. And to counter this, for example, in 2011, that was almost 10 years ago, Amazon was able to deploy a change into production on average every 11 seconds, right? So it's not lead time of weeks or months. It's basically you write it, you go through the CI, and then it's on production, right? So it's not possible with a big ball of mud. Scaling issues are very common with big ball of mud type of systems because when you have a huge system that has different functions or different parts that provide those functions, they might require different resources to scale. Like, for example, when you have a system that produces PDFs, rendering a PDF requires a lot of memory. It doesn't require too much of computing power. On the other hand, if you want to sign a PDF and provide an electronic signature, it requires a lot of computing power. So it's really hard to scale on both axes, like with the CPU power and the memory, because this is basically expensive, right? So big ball of mods provide scaling or have scaling issues as well. So let's get deeper into that topic. How can you scale a system? There are actually three dimensions of scaling. You can scale by hardware. So basically, you add more application instances, and then in front of the nodes in your cluster, you provide a load balancer, and this load balancer basically distributes the requests to specific instances. It might do by the round robin fashion, or it can have another strategy, but usually, and that's what you can see, for example, with more more old type software or legacy software is that the load balancer will use sticky sessions because application instances have some caches, or you use session and you keep data in session for the user. So load balancer will use sticky sessions for load balancing. So each user will actually get assigned to an application instance, or not the each request or anything like that. So this degrades the scaling a bit. So you can scale by hardware. That's why one way of scaling. So you provide more instances of the same application, and by that you hope that you can answer more requests. The other option is you can scale by partitioning. So you can just provide this load balancer with some setup that tells that if you have a user that starts with the name, start with a name that starts from A and up to H, then assign that user to one instance. If the user name starts between J and T, then assign that user to another instance. And then for all the rest of the users, just use third instance. That's one way. Another way of partitions, or another way of scaling by partition, right? And then microservices are about functional decomposition. So you basically scale by the functions that the system provides. So you have a separate service for generating PDF from our previous example. You have a separate service for signing the service, and then you can scale each of those independently. So you can use those two previous dimensions for scaling. And when you scale by using functional decomposition in front, then you're not worried about things that I need to provide a huge machine with lots of CPU power, and both CPU power and lots of RAM, just because I have a PDF generation and PDF signing in the same service. So this is basically the heart of microservices. Okay, so that's about the scaling thing. Then let's get back to the big ball of mud. In my opinion, and it's a very common opinion actually, it's impossible to test such a vast system end to end, because there's so many things that you need to look into that it's basically impossible. And this makes the software unreliable, because if you don't test, you don't get reliability. Okay, there's one more thing that I want to mention. Big ball of mods tend to be written in obsolete tech stacks. Usually that's because this is not the software that is written yesterday. It's a mature software or legacy software, depending on how you want to look at it. And by having obsolete technology stack, you will not be able to attract smart developers. And this might be actually a problem if you're working on legacy code. It's really hard to attract people to join you because, well, smart developers are rarely interested in money only. And hiring smart developers is getting harder and harder. When candidates hear what technologies you use in your legacy project, they might not be excited about it, and you want to do something about it. Right? This might be somewhat fashion-driven development, but still, it is something that you need to consider when you're, I don't know, a project manager or a team leader that wants to hire people. So, yeah, that's worth looking into it. Anyway, so yeah, what you want to do is you want to break from the monolith. So you want to decompose your big ball of mud or the monolith into smaller pieces, and by doing that you will avoid all the issues that I just mentioned. But you need to be very aware of what you're doing, because architecture matters. Why architecture matters? It's because it provides for non-functional requirements of the system, like the qualities like scalability, maintainability, extendability, security. So if you break the thing down in a wrong way, you will not improve things. You will only make things worse, because that's another very common anti-pattern that I've seen a lot. A distributed monolith, which is both inefficient and very hard to understand. Okay, one thing to remember is that because of Conway's law, microservices are very hard to implement in a traditional setting, like, for example, waterfall, or something that I like to call corporate Scrum. So this is what I mean by corporate Scrum. Even though it looks like Scrum, it's not Scrum. It's basically waterfall disguised as some kind of agile way of working. Like, we have mandatory processes and tools to control how individuals interact. The software is the working software is okay, but as long as it is comprehensively documented. So in the summary, while the items that or the agile principles sound nice in theory, the enterprise company will not let go of the items on the right, on the old way of doing things. And in such settings, developing microservices, because of the Conway's law that says that systems reflect the teams that work on them, it's really hard to do microservices right. So this is some kind of a warning before you set off on developing a microservices-based system. And now let's think about, how do clients reach the system? So let's say that we have a backend for the system, and now we want the front end to reach that backend. So what are the typical ways of doing that? If we have a small application or set of small applications, we have different kinds of clients consuming the services API. And there is a couple of problems that I can see here. Like, for example, since we're using very fine-grained APIs, and it usually is this, like, for each screen of the for each screen in the application, you actually need to provide some kind of a REST endpoint or something like that. And if the front-end developer starts working on that, they can see that, oh, I need to do something like 50 requests before I can display a view. And what's wrong with you? Why can't you just provide me one answer, one endpoint, or anything like that, so that I can just display the screen with all the data already in? Then the problem with fine-grained APIs is that clients know too much about internals of the system, so it's difficult to change the architecture and those APIs. And the thing is that if you want to change the API, you need to roll it out in a synchronous manner, because you need to update like things like iOS app and the API at the same time, which is, well, really hard to do. And then you might have some services that use inter-process communication mechanisms that you don't want to use outside the firewall. And the final thing is that if you ever have any integrations with third-party apps, those third-party apps developers want you to develop an API that is stable, so that they can use it for months or years, something that doesn't change every now and then, like every week, right? So one solution to this problem is an API gateway pattern, which looks like this. So basically, we have a firewall in front of our DMZ, the militarized zone. And behind the firewall, we have an API gateway, which basically takes care of forwarding everything to the actual backend. But by providing this API gateway, you can do things like request routing and use a reverse proxy, right? You can have things like API composition. You can have switching from HTTPS for the external routing or external traffic to HTTP. So internally, you can use HTTP, but you don't expose your microservices with HTTP. to the outside world. Why would you want to do that? Because HTTPS is more resource consuming, right? You need to actually encode the HTTP request and decode the HTTP request response. Sorry. So you can choose if you want to have one size fits all API, or you can have APIs per client type. We'll talk about this in a minute. And the final thing that API Gateway provides you with is edge functions, things like authentication, authorization, rate limiting, caching, collecting metrics, login requests. So how do you develop such a gateway, API gateway? Well, one thing is that you can use some things like microservices chassis for Java world. That would be Spring Boot with starters, or Micronaut, or Helidon, something that you just use to provide all the required stuff, and things like connectivity, connecting to other services and so on. And yeah, but how do you do edge services? You can actually have edge services separated from the gateway, and that's one of the pros of doing that. It's that it allows you to separate concerns. But there is also one thing to consider. If you separate them into another layer, you get an additional network hop, which brings more latency and additional complexity in your setup. So this is something that you need to consider. You can also embed the edge services in the gateway. So this is how it would look like. So you have, you have an API gateway, and you have two actually layers. Each module either routes requests to backend services, or composes responses from multiple requests to the backend. And I've mentioned that you can also have different APIs for different client types, and this is something that is called backends for frontends. So you can have a separate API for mobile client, a separate API for single page application client, and then you can have a separate API for third-party client, and use API gateway pattern to implement that API. The common layer, the edge functionality on those two slides, refers to edge functions, right? And this is something that you probably want to have developed by a separate team that owns it, because you want to avoid code duplications. So this is something that that might be provided by some other team inside your organization. Okay, so how to implement API gateway pattern? One thing that you can do is use the off-the-shelf product service, or product or service. Like there on AWS, there is API gateway. Other cloud providers have their own products or services. So that's one option. It provides edge functionality, but they are usually somewhat limited in their functionality. Like they don't support things like API composition, or well, basically you need to run on a specific cloud provider, and yeah, it might not be the best option in your case. So what is quite common is using gateway products, like for example Kong. Kong uses Lua scripting language for plugins, which allow you to add some more functionality. There is traffic written in Go, and then there is Tick, another one that is off-the-shelf product that you just deploy and configure for providing API gateway functionalities. But you can also roll your own API gateway. And for example, Netflix developed the Netflix Joule. There's a second version already available, Netflix Joule 2. The version 1 is not supported anymore. And the version 1 integrated neatly with Spring Boot, but it's not supported anymore. So if you're in Spring ecosystem and want to use Spring for everything, you can use Spring Cloud Gateway. That's a project from Spring Cloud that provides pretty much the similar functionalities for developing your own API gateway. One thing that you want to consider, because so far we were talking about, or somewhat assumed that we're talking about, it was assumed that we're talking about REST-like APIs, but REST is not the only way of developing web applications, and something of a new trend coming from Facebook is using graphs. So the idea here is very simple. Let's invert the control. Let's use the inversion of control principle. Instead of trying to straitjacket clients into specific APIs, let's choose clients what data they need from the system. And this is graph-based APIs. The pros of using graph-based APIs are that they give clients control over what data is returned. There is one API to support diverse clients usually. The third statement is somewhat a simplification, and I would say that it's a bit too much, but it is in a way it lets you treat the system as a database and let clients execute queries on it, right? So there are some implementations for Java world, for example, from Netflix OSS. There's GraphQL, which is a standard of graph-based graph-based APIs. And this specification is provided by Facebook. They use it in their products. There are many implementations of the standard. In Node.js, there's Apollo. There's already mentioned Netflix implementation for Java world. So yeah. And then another way of implementing a gateway is using a server-side UI. So the idea here is that we want to invert the control even further. So we're embedding the client in the gateway, and use the client just to render the views. But pretty much all the logic or the UI logic is embedded in a gateway. Of course, this requires you to use sessions and have a session on the gateway for a specific user. So it's a bit unorthodox, I would say, but it has its own pros. So let's take a look on typical layers of a web application. So we have a JavaScript client. There is a communication layer, which is basically AJAX communication. We have an API gateway, and then that API gateway forwards requests from the client-side UI to backend services. And this is a very common high-level web applications architecture. But with my proposal of server-side, with my proposal of implementing a gateway with server-side UI, you can actually break down this into things like on this slide. So you use server-side UI that is embedded in your API gateway, and the JavaScript client and communications are basically automated, because by using server-side UI, I mean you write the code that runs on the server side, in this case in your API gateway, and this code takes care of all the logic, all of getting to backend services and so on and so forth. It hides all the complexity, but it also provides the client side, the browser, or it might be a phone application, with very simple information about what should be rendered and how should it be rendered. So one very common implementation of server-side UIs in Java world is Vaadin framework. So yeah, I wanted to present you how this server-side UI would work with Vaadin. So yeah, let's take a look on some sample Vaadin code. This is written in Vaadin. I think it's Vaadin 8. So you write your application by using using components. In this case, we have like 3 components here. There is a layout component, which basically takes care of laying components that you add to it. There is a text field with the name name or a caption name, and with a button with a caption greet. And as you can see, we add those 2 components to the layout, and then we add a click listener to the button. This is Java code. This runs on the server side. So when the application is actually reached by the client, by the web application, what happens is that this application will answer it some initial HTML, CSS, and images for skinning the application. There will be some JavaScript that is the engine of this server-side UI framework. And this engine will take care of forwarding all the events to the server side and rendering the responses in the browser. So this usually takes something like 300 kilobytes. So yeah, what happens when you access the application with the code that we have here is that, again, we have a text field with caption name. We have a button that says greet. They are added to a simple layout, and that's it. Then you can type into this text field and click the button great. And what happens here is that the browser, by using Ajax, sends a request to the server side with 2 informations that, okay, the user typed their name into the text field and they clicked on the button. And that's how the click listener on the server side is invoked, right? Because we added a click listener, and the framework knows that, okay, so we got a request from the browser saying this button was clicked, so we now need to invoke this click listener. And the nice thing about Vaadin is that it takes care of synchronizing the state from the browser to the server side. So when you get the value of the text field, it will actually have the content that the user provided there. So it makes developing web applications really easy, because you don't need to be worried about things like transport, developing with Ajax requests and so on and so forth, right? You just write Java code. If you're a Java developer developing a web application with Vaadin, is very simple. The only thing that you need to understand with it is the component model. But if you ever wrote any kind of desktop application, like using Swing or JWT or AWT or SWT, it's really the same concept. So you have components. Those components can have state, and the overall state of the application is the summary of the states of the components. Vaadin just provides the synchronization between the browser, which is using as some kind of a screen for rendering the application. The actual logic runs on the server side. So yeah, that's what happens when we execute the listener. So we want to show a notification, and this notification will contain the name of the of the user that they provided in the text field. So that's what happens. The answer is that, okay, the backend response, you should display a notification in this specific text. And that's how server-side UIs in general work. Okay, so I think I forgot to mention that in the beginning, but if you have any questions or anything like that, I would love them to be on Hopin chat. So if you want to ask about anything, please write the question on the Hopin chat. I will join after the session and I will try to answer those questions. Okay, so that's basically it. We have a notification displayed, and that's pretty much it. So I want you to think about one thing. This is how much code you needed to develop this kind of application. And now think about how much code you would need to write if you wanted to achieve the same by using, I know, Spring Boot and some kind of front-end technology, or maybe, I don't know, some other backend frameworks, or even just servlet specification, right? And making it an Ajax application, making it a secure application so that you don't get things like cross-site request forgery attacks. This is all covered by Vaadin for you, right? So, yeah, the question is, what should we do? And how should we approach the task of building a microservices-based system? And the answer is, as usual, it depends. So if you want to use server-side UIs, the one thing that you need to remember is that it gives you a lot less control on the client side. But because you're developing by using a front-end by using a backend library of components, and those components have corresponding front-end components, but you don't access them directly. You just use the Java API for building that application. But there are some things to consider because you will get increased development speed. This might be a very familiar programming model for backend developers if they ever developed for desktop or for mobile. So it's really worth considering. There are many options to choose from. You can have an API gateway, you can have an API gateway with GraphQL, or you can use server-side UIs embedded in your gateway. And one thing to consider is that if you think that good architecture is expensive, then you should try bad architecture. Okay, I guess that's all I had to say. So over to Studio.